Next protocol, that is, yesterday we studied about one distance of vector protocol. Okay, that was RIP. That means routing information protocol. Okay, and today we are going to study one of the link state protocol, that is nothing but OSPF, and this is widely used nowadays in every network. Okay, so but that too within the AS. Done. Next, first one, open shortest path first. What is OSPF stands for? Open shortest path first, and this is a layer 3 protocol. Which layer? It's a network layer protocol, and link state, it is a link state routing protocol. That means based on this shortest path first or a Dijkstra algorithm is going to find the best path. What was the algorithm that was used in the distance vector? It was a Bellman-Ford. Here we use Dijkstra or shortest path first, both in OSPF and ISIS. Okay, we use the shortest path first or a Dijkstra algorithm. Okay, and in RIP protocol and IGRP protocol, we use Bellman-Ford algorithm. Okay, so it supports classless routing protocol. What do you mean by this classless routing? MAC address.
Sorry, for subnet mask.
Subnet mask. Okay.
It's not fixed area.
Okay.
In class A and class B.
Okay, which supports, I mean, in simple words, it supports VLSM or CIDI. Okay. And protocol number is 89. What was the protocol number of RIP? 520. And what was the AD value? 120. What is this protocol number of the OSPF? 89. Okay. And AD value is 110. Okay. So here, which will be having full topological information because of what? As I said yesterday, because of the LSA. Link state advertisement, it will have the full topological information where it is connected in, where it is configured with the OSPF. Okay, and it uses some multicast addresses, that is 224.0.0.5, just to exchange some hello messages between the neighbors, and 224.0.0.6, which is used by the DR and BDR to send some update to the neighbors. Okay, so we have DR and BDR here. Okay, we'll discuss it later in detail. Yes, so just to send some message from DR and BDR routers to the DR other routers, we use this, the routers uses this multicast address. What is the range of class D? Class D. Class D. 224 to it is reserved for multicasting. Can you see the same here? 224. Okay, 224.0.0.5, this is used for what? Hello messages. Okay, initially it is used, and then 224.0.0.6, which is used by the DR and BDR routers just to send some updates to the DR other routers. Okay, so here the cost is metric. What is the metric of this OSPF? It is cost. What was the metric in RIP protocol? No. Yeah, it was least hop counts. What is the metric in OSPF? It is cost. What exactly the cost is? If the bandwidth is high on the link, then the cost value will be low, and the lowest cost will be preferred as in OSPF. Okay. However, your bandwidth increases, the cost value decreases, and always this OSPF router prefers a lowest cost value that can be the best path to reach the destination. Clear? So it is a IGP protocol, isn't it? IGP means what? Interior Gateway Protocol. Okay, and it supports unlimited hop counts. What was the hop count in RIP protocol? It just jumps 15 times. What? RIP. And we don't have any restrictions in OSPF. It can send its routing information to any number of routers. But if they have to be configured with the OSPF, that's it. Okay. So this is some basic information about the OSPF. Now we'll jump into the OSPF, exactly how it will exchange some information or how it will establish a neighborship. So all this kind of thing. Okay. So just to find a neighborship and to forward the routing table. Okay. So here it has to go through some 7 states. 7 states of the OSPF. First state is what? It is called down state. Okay. So how they will become neighbors? OSPF process starts with a message called OSPF hello message. Okay. This is what? Kind of an introduction between the neighbors. How they will start to talk with each other? By sending hello messages. Okay. In that first state is what? It is a down state. So what exactly the down state is? If we have configured the OSPF protocol on the router due to some problem, and even if it is not configured with the OSPF protocol, then the neighbor router is not replying for the hello message. So this state is called as what? Down state. If you have configured the OSPF and still the router is not replying back for your hello message, or even you are not configured with the OSPF, and in that case also it will not reply back for the hello messages. Okay, so this state is called as what? Down state. Okay, now let's say like we configured everything and both are exchanging some hello messages. So that is the init state. Okay, we call it as a init, or even we can say it as a initial state. Initial state. What happens here? In this state, both neighbors exchange the hello messages. After port is up and after configuring the OSPF on both the routers, if they start to exchange the hello packets, that is called as what? Init state, initial state. Then it will go into the two-way state. So what happens in the two-way state? Here the neighborship will get established and routers will build the neighbor table. Okay, I think yesterday I said you, it maintains 3 tables. What are those? First one is neighbor table, topology table, and the actual routing table. Okay, so this OSPF routers, they will maintain, okay, this neighbor table in which state? In a two-way state. When they, after exchanging some hello packets, yes, getting introduced with each other, they will exchange their LSAs. Okay, so after that they will build the neighbor table. Understood? So what will be there in the neighbor table? The first thing it will be having, that is a router ID. Router ID is nothing but what? It's kind of a name of that router in the topology. Router ID, that is also same like your IP address of 32 bits. Size of this router ID is what? Again, 32 bits. That is a unique identifier an OSPF router can have, and this router ID is decided based on this order given below. Okay, how we can decide which IP address can become the router ID? Router ID is nothing but what? It is a name of that router. It's a representative name of that router in the whole OSPF topology. Understood? The first one, it gives the preference for manual router ID. Okay, it is highly preferred. Manual router ID means what? Being a network engineer, okay, network administrator, whatever the ID you want to give, you can give any IP address within the range what we have, 0 to 255. Okay, you can give that one, and that will become what? That will become what? Router ID. Understood? And if the network administrator is not giving any router ID manually, then it will go for what? Loopback interface IP address. That too, highest one. If you have configured loopback addresses on that router, okay, just like 1.1.1, 2.2.2.2, okay, or 3.3.3.3. So it will go forward last one, 3.3.3.3. Just it will become what? Router ID. Understood? And even though you're not configuring any kind of a loopback addresses, you are not giving any loopback interfaces or creating any loopback interfaces, then it will go for what? Highest IP address of the physical interface. Obviously, we are going to assign IP address, right, to the router ports. So it will check which is the highest one among these. Okay, so based on that, it is going to choose one, and that will be what? The name of that router in the OSPF topology. Yes. And the RID, router ID, must be unique for each OSPF process in a OSPF domain and on the same router also. Okay, it should be unique. You can't give multiple on multiple routers. I mean, you can't give the same on multiple routers. It should be really unique in the topology. Understood? Next, we have something called LSDB. Okay, what is LSDB? It is link state database. So what exactly this one is? As I already said you, the routers will exchange some LSAs. What is LSA stands for? Link state advertisements. Okay, which will be containing a lot of information about that router. Okay, just like router ID and the cost and the interface IP address, what is the status of that interface. So everything, it will be there in the LSA. By that, the other router can understand, yes, there is one router which is having this routing table. Get it? So what exactly this LSDB is? The routers will build a lot of information about the network, like routers, link, IP address, status of that interface. So other information it will build, and that is called as what? LSA. And then the router will flood the information to all the routers just to know the same information. There is one condition in the OSPF. What is that? Until all the routers have the same LSA information or same routing table, till then they will exchange a routing table with each other. Okay, there's one condition, what? Every router should have the same routing table. Understood? I mean, it should know everybody in the topology. Okay, if it is don't have, then it will ask for it. When it will ask, we have again some exchange state and loading state. So in those states, it will ask for it. Yes, this is what the extra route you have. Can you just please give it to me? And that router has to give it to it. Okay, this is what a condition we have here. Yes. So what will happen? They will flood the information. So all router know the same information in the topology. Okay. And at the end, every router in the internetwork must have the exact same information about the internetwork. Same thing I said you. Yes. And each LSA, that is link state advertisement, is a data structure with some specific information about the network topology. Okay, what is LSA? It will be having some information about that router. Okay, the same thing I said you. What will be there in the LSA? You can see here. This is the content of that LSA. It is having router ID, interface, IP address, and what is the status of that IP address? Sorry, interface, and then the cost value. Okay, here value we have. Here also we have what? Cost value. Where we have seen cost value before? In which protocol? Cost value? Yes. Yes, Murali. STP, right? There we had cost value, route path cost. Remember? So here also we have cost. Understood? Okay. So what is this LSDB? It is a collection of all LSAs. What is this? LSDB means what? It is a collection. Collection of what? All LSAs. What we have in the whole topology. Okay. So next, what was the previous state? What we studied? Previous state. The third one. Two-way state. What happens in the two-way state? What happens? They'll build a neighbor table. They'll exchange some hello packets and then it will go to the two-way state, and here they will find the or establish a neighborship, and they'll build what? Neighbor table. So after building the neighbor table, they will come to the exchange start state. Okay. In short, we call it as a X start. What is this? Exchange start state, where the election process takes place. Here also we have some election. Election of what? DR and BDR. DR is nothing but what? Designated router, and BDR stands for backup designated router. Okay, these are the two router roles we have in the OSPF. Okay, we'll discuss what is the role of these DR and BDR later. Yes, so here the election takes place like DR and BDR, and even master slave also you can say. So this election will take place here. What is master slave? The router who is having the router ID is highest, that will become as a master and remaining as a slave. Okay, this is what choosing the master and a slave routers in the OSPF topology. Okay, whatever the router which is having highest router ID, that will be considered as a master and remaining as a slaves. And after election, they will go to the exchange state. So what here they will exchange? Before this, the exchange started. Okay, exchange of the devices. There it elected some routers at a DR at BDR, and then it will come to the exchange state. Here they will compare the number of LSAs what they have. Okay, you can see here. Here the router will exchange the header of all LSAs toward each other, but not database. Okay, let's consider we have two routers here. We have two routers which are connected with each other, and this router 1, which is having LSAs like LSA 1, LSA 2, LSA 3, okay, LSA 4. So this is having 4 LSA information, and router 2 is having LSA 1, 2, 3, 4, 5, 6. Okay, during the LSA flooding, what they will do? They will exchange this LSA headers, only headers. Header means what? Only counts of the LSAs. Router 2 says that, yes, I'm having 6 LSA headers. So how much you have? It will ask for what? Router 1. Okay, router 1 says that I'm having only 4 LSA headers. We will compare that one. So which router, router 1 compared to the router 2, which router LSA I have and what he is having. Okay, I'm also having LSA 1, he is also having 1, 2, 2, 3, 3, and 4, 4. Which are missing? Which are missing? 5 and 6. And router 1 will ask for it. This is my right to have these LSA 5 and 6 also. Please give it to me. Okay, but that will happen in the loading state. Okay, but now you can see here. Here they compare the number of LSAs the other router has. And if the other router has more LSAs, then they will ask to send only required LSA information. Same thing I said you. What they'll do? They'll compare the number of LSAs between those two routers. Okay, if any LSA is remaining or it's not there in the router 1, then it will ask for it. Okay, and here they will exchange only what? Headers, not the actual database. In the which state? Exchange state. Okay, then what happens in the loading state? Here routers will exchange the database of those empty LSAs header which are sent in the exchange state. Now they will exchange this 5 and 6 with the help of these 3 messages. So what are these 3 messages? First one is a LSR, link state request. Okay, second one is LSU, link state update, and last one is LSAC, link state advertisement. What they will do, router 1 will generate the link state request. It will generate what? Link state request for what? LSA 5, and it will send it towards the R2. Okay, because 5 and 6 are missing, right? They have to get it from that one. Router 1 has to get it from the router 2. Then only it will be having the complete information of the OSPF topology. Understood? So once this router 2 gets a request of this LSA 5, it will send LSU for what? LSA 5. Okay, and that will be reaching the router 1. That means now this router 2 is sending the whole database of the LSA 5 towards the router 1. Okay, once this LSU reached the router 1, it will acknowledge it. Router 1 will send the acknowledgement for what? For LSA 5, and that will be given to the router 2. Okay, so the same messages will be exchanged for every missing LSA. So it will be exchanging same 3 messages for LSA 6 also. Understood? So this is what happens in the loading state. Actually, it is loading the database which are missing into the router 1. Am I clear? Is it clear? So they will exchange sent in the exchange state, means here they will ask for what? More recent LSAs that have been discovered but not received in the exchange state. Okay, after this it will go to the full state. What is full state? Here the routers will be having the complete information of the neighbor devices, or even you can say nobody sleeps. Okay.